Okay, so by definition, for a single slit, definition for diffraction is that it's a bending of light as they travel around obstacle or pass through an aperture or slit comparable to the wavelength of the light wave. So at the start of this chapter, when I discuss about Huygens principle, I show you what will happen if the slit separation is comparable to the lambda. Lambda is the wavelength. So if it is comparable, then basically it will produce a circular wave over here. Okay. If it is too big, you can't see the changes from the plane to the circular wave. Okay, this wave will produce a diffraction pattern over here. Okay, A here is the slit separation. The pattern that you can see over there is something similar to this one. Okay, the most obvious trait is that dia lambat lagi. Okay. The most obvious trait for the diffraction pattern is that in the middle here you have the highest intensity compared with others. Okay, so this one is the intensity graph. Yang the right hand side ni intensity graph. Means that this one paling terang lah, easiest way to say it. And then even in terms of the width of the central here, it is actually much larger compared to others. In fact, it is actually twice as large as others lah, 2 kali ganda. Nanti ada formula dia. So basically the formulas are pretty much the same, similar. You have constructive diffraction punya formula, you have destructive destructive diffraction formula, and then you have a formula to calculate the central bright maximum. Okay, and then the main difference between single slit and double slit, okay, double slit is the young double slit. So the width for each fringes are the same for young double slit. Compare with single slit, the width for central is wider. Okay, and then in terms of intensity, kalau double slit it reduce slowly. Dia still reduce, okay, because the energy intensity tu memang reduce lah sebab dia spread out kan. Tapi kalau yang single slit ni lagi more obvious, so you can immediately see how many fringes that can be produced like that. You can immediately calculate. Okay, and then another trait is that for single slit actually produce a non-uniform pattern compared with double slit that is much uniform. Okay, so any question? Any question you want to ask?
No, sir.
Okay, this one is just a basic. This one is just a basic things. Okay, so after this, I'm not going to go through the derivations in terms of calculations. So after this, we just focus on how to use the formula. So I'm going to show you how to use the formula after this. So this one is A. So if you want to use formula, the first thing that you guys need to know is that about numbers of order. So if you guys still remember number of order, kalau dia beri untuk fringes kan, untuk yang double slit, for destructive order, you have to minus 1. Okay, but this one you don't have to. So this is the only time that you have to, the only time you have to minus 1 is for dark yang double slit if they give you in fringe. Okay, other than that, basically just have to use the numbers. Okay, so the middle here is what we call central bright maximum. Tapi kadang-kadang central bright. Okay, and then this one is what we call the first order. Okay, so order numbers here we use as n instead of m. Kalau before this we use m kan, kalau yang this one we use n. Okay, and this one, the second bright fringe, is what we call, second order. Third bright fringe is the third order. Okay. In terms of for dark, so this one is your first dark fringe, n equals to 1. Second dark fringe, n equals to 2. Third dark fringe, n equals to 3. Okay. So first dark fringe is like called first dark fringe. So n and numbers of fringe is the same. Okay. Kalau yang this one, first bright. fringe. Okay, so the easiest way to remember, numbers of fringe, numbers of order are pretty much the same. It's the same number, so you don't have to worry. Okay, understand or not? Dia macam kecil sikit, saya tak sure kamu boleh bezakan tak, saya tunjuk.
Understand, sir.
Okay. And then instead of, dulu kita ada D kan, slit separation kan, ada dua slit. Now we just have to use A je, slit size tu. Okay, so basically you still have constructive and destructive diffraction. Okay, for destructive we call this one as maximum or bright fringe. Okay, so we still have the two main formula here to calculate y. Y here masih sama lah, jarak daripada tengah tu. Okay, so the difference between yang double slit and this formula, number one, instead of we have small d, now we have small a. Okay, small a here is the slit size. Ada tak saya tak tulis tapi kamu tahu lah, a ni adalah size of the slit. Okay, and then if you notice, n dengan n plus half ni terbalik. Okay, kalau dulu n plus half tu untuk destructive, right? Dan constructive adalah m, tapi yang ni dia terbalik lah. Similar to antiphase punya interference. So untuk constructive dia ada half, untuk destructive dia tak ada half. Okay, and then N1, N2 tu dia still apa tu, first bright, second bright, dia dah tak ada -1 lah. Okay, macam ni. And then ada extra formula untuk width tu, central width maximum tu, which is this formula. Okay, so the formula is basically lambda d over a, cuma you have to multiply by 2. So basically the size is twice compared with other punya size. Okay, kamu boleh dengar tak suara saya ke terganggu?
Dengar, sir. Boleh dengar dengan jelas.
Okay.
Clear, sir.
And then this one, kamu ada extra formula actually for this one. Actually tak ada extra cuma yang double slit you still have this formula, cuma saya tak tekan sangat itu. Okay, sebab yang double slit dia jarang suruh kira numbers of order, but this one dia selalu suruh kira, so you might have to use this formula. Okay, yang dua ni. Okay, dia formula adalah a sin theta lambda n, cuma yang ni depends lah, untuk constructive dengan destructive dia sama ikut yang yn tu. Okay,
Sir, saya tanya.
yes.
Kira macam beza yang single slit dengan double slit. Kalau double slit N to M, kalau
Betul.
single slit dia pakai N lah kan?
Yes, betul.
Lepas tu sir, kalau yang dekat single slit starting untuk dia punya tu start daripada 1 sir?
Betul. Betul.
Okay.
Sebab dia tak ada yang dia central bright tu, dia terus pakai formula ni. Yang tengah-tengah tu dia terus pakai formula ni. Lepas tu yang lain tu dia dah panggil first order terus. Dia tak ada M sama dengan 0. Dulu ada kan? Yang ni N dia terus 1. Okay.
Okay sir. Thank you sir.
Very good. Okay, and then ada lagi satu benda yang dia selalu suruh kira is max numbers of order. Berapa banyak order. Okay. When they ask you to find max numbers of order, basically you have to use these two formula. If it is constructive or destructive lah. So we assume that maximum numbers of n when this values over here is maximum, which is equals to 1 lah. So sin is equals to 1 when theta is 90. That's why I write it over here. Okay. And then this one is max number of order. Ada berapa banyak order. And then you still have to focus on numbers of fringes. Kalau bright fringe, you have to do 2n plus 1. Kalau dark, basically 2n. Okay. Kenapa? Okay, saya tunjuk okay, katakanlah kamu kira. Katakan soalan dia suruh kira numbers of bright fringe, maximum numbers yang terbentuk lah. So basically you want to calculate n, you use this formula, ataupun kiri kanan lah, you use this formula, you get n, and then katakanlah n kamu example n sama dengan 3.7. Okay, the first thing that you have to do is that you have to, macam banyak sangat saya nak bikin lagi, kita tukar pada 2.7. Okay, the first thing that you have to do is that you have to round it off. Okay, bila kamu round it off, it doesn't mean that you have to bunda ke nombor yang terdekat. Instead, you have to round it off to a smaller number. A smaller number here would be 2. Smaller round number is 2 lah. Jangan bundakan dia ke 3. Sebab apa? The third order tu, you cannot see dia punya fringe lagi. You saw here is 2.7 lah. Tak sampai 3 lagi. So, round it off to a smaller round number. Tak kisah 2.7 ke, 2.99 ke, 2.1, roundkan dia kepada 2. Okay. So, what will happen here, kalau untuk dark ataupun bright, kita bikin bright dulu. Okay. Pakai color hitam je. Saya ingat macam nak pakai color lain-lain, tapi nanti saya takut dalam exam pakai hitam putih juga. So, biar use same color, hitam putih. Okay, yang tengah ni dia panggil central bright max. Okay, yang atas ni first dark, first bright, second dark, second bright, third dark. Third bright tu dah tak nampak. Okay, so this one is your dark, this one is your dark. So this one is central max. So this one is when n is equals to 1. This one is n equals to 2. Okay, so basically if you want to calculate second dark. Okay, jadi kita boleh tengok example, tapi tak apalah, saya try show kat sini. So, apa yang berlaku dekat sini, you can see that this one is your central max, and then bila dia kata numbers of order to 2, basically you can count 1, 2. Okay, and then you have to multiply by 2 because dia ada atas bawah, and then tambah 1 sebab dia central max. So that's why the formula is like this. But fringe, you have to multiply by 2. So tadi 2 kan, darab 2 jadi 4, atas bawah tambah tengah 1. Okay, tapi kalau untuk dark, okay, so basically katakan yang ni tak nampak yang atas kan. Let's say dia tak nampak yang this one tak ada. Mana saya nak hilangkan dia? Katakan yang tu tak ada. So basically kamu hanya nampak 2 dark. So 2 dark ni tambah atas bawah so darab 2 lah. Tapi central dia ada, tak ada, dia tak ada tambah 1 ni. You understand tak?
Understand, sir.
Okay, nanti kita cuba buat soalan. Nanti maybe ada example and then you can see clearly lah. Jadi kita cuba buat. Itu favorite question. They normally they want you to find the numbers of fringes ataupun maximum numbers of order. Kalau order tu kamu gunakan je, and then kamu tukarkan daripada nombor bulat je dah cukup. Okay, dia kata numbers of fringe and then you have to calculate. Kira lah. Okay, the last subtopic is about diffraction grating. So diffraction grating basically if you have surface like this, right, and then on that surface you have a slit, banyak slit, banyak slit rapat-rapat. Okay, and slit tu kalau banyak duduk rapat-rapat, itu dipanggil sebagai diffraction gratings. Okay, ada main quantity here which is D, small d. Small d here represent the slit separation. Itu dia punya small d. Okay. You have a formula for d which is d equals to 1 over n. N in numbers of lines per unit length. Contohnya n is equals to 100 lines per mm. Maksudnya 1 mm ada 100 line. Ada banyak sangat lines. So if you want to calculate separation, kamu kena 1 over this one. Okay, and remember if you calculate this one, normally the unit would be in mm or cm. So unit dia bukan unit SI lah. So if you want to convert mm to centimeter, normally you would like to divide, mm to meter kan, kamu kena bagi with 1000. Tapi remember that this one is per. Okay, so kalau per dia terbalik lah. So the easiest way to avoid confusion, basically you calculate n yang diberi ni kan, kalau diberi dalam lines per mm, straight away you substitute inside this formula. Okay, so your slit separation will be in mm as well. So daripada mm tu convert ke meter dia senang, bagi je 1000. Okay, that one is much easier. Before you substitute inside this formula. Okay. So you have one formula which is d sin theta is equals to n lambda. This one is for diffraction grating. Macam mana nak tahu itu adalah diffraction grating? It's either they say specifically it's about diffraction grating, or they give you something with a units of lines per millimeter, per cm lah. Okay. And normally the question will still ask you to calculate either angle or dia punya maximum order. Sama concept, we use maximum order when sin theta is equals to 1. So this one becomes 1 lah. Okay. Dan then the pattern sama macam diffraction pattern yang kat atas tadi. Okay, dia ada central max fringe, first max fringe and then second max fringe. Kalau N0 tu central je lah. With N0 everything jadi 0. So basically kalau formula ni jadi 0 lah. Okay, this one is example for the pattern. This one is single slit, 2 slit, 3 slit, 4 slit, 5 slit, 7 slit. So slit ni memang dia rapat-rapat. Okay, tengok dia punya jarak dia ni, D ni is 150 micrometer, which is very small. Slit separation. Okay, any question?
So far no sir.
Okay, there's no question. Cuba kita buat soalan. Okay, and then let's see whether you guys really understand this one. We start with the diffraction first. So it's question 12 from your tutorial. I think this one is straightforward lah. Dia kata a light of wavelength 600 nanometer falls on 0.4 mm wide slit and form a diffraction pattern 1.5 meter away. So here dia memang cakap ini adalah diffraction pattern. So straight away you know you have to use formula for single slit. Distance of the third bright fringe from the central maximum. So they want to find y with the fourth bright fringe kan. Then the second question, they want to find width of central maximum. Okay. First of all, you have to take out the information. 600 nanometer tu represent apa?
Lambda.
Yes, very good. Yang 0.4 millimeter?
A.
A, yes. And then screens 1.5?
Capital D.
Yes, capital D. Okay, kalau dulu kamu ada capital D dengan small d kan, sekarang ni small d tu dia jadi A lah, small a. Okay, basically you have two formula. Yn equals to n plus half, kita balik kan, lambda d over a. This one for constructive. Nak cakap constructive tak tepat kot. So it's more like, kan saya pakai constructive. So constructive tu biasa kita pakai apa tu untuk interference, constructive interference, destructive interference kan. Kalau ini more suitable if you use maximum dengan dark lah, maximum dengan minimum, jadi sesuai kot. This one is for bright. Kan dah habis, ada ruang. Yn to dark. Okay, macam biasalah saya list down the equation so that when you try to solve, it is much clearer. Okay, which one you want to choose? Bright or dark? Untuk soalan A.
Bright.
Right, sebab apa dia obviously dia kata third bright fringe. So N dia sama dengan berapa?
3.
3, very good. So basically we want to use this formula untuk bright. So Y3 is equals to 3 plus half lambda is equals to 600. D 1.5. And then A, okay. So apa namanya?
7.88.
7.88
Okay, very good. 7.88
-3.
dan -3. Okay, biar je jawapan situ. Okay. So kalau macam ni lah dalam exam maybe this one dia akan kasih konsep, maka konsep satu. Maybe maybe. Kadang-kadang tak adalah. And then substitution. If you substitute everything correctly, you get 1 mark. So say, try tunjuk kalau dia tanda. So K1, this one dia kata gantian 1 markah. Final answer with unit, jawapan dengan unit 1 markah. Okay, jawapan saja tak ada unit, tak ada markah jawapan tu. Salah kira tak ada markah. So basically kalau kamu tak tulis ni, katakan kamu test tulis ni 2 je, tapi ada markah ni, dia boleh kira daripada dalam sini lah. So kamu tahu, dapat 1 markah juga kat situ. Okay, soalan B. Width of the central maximum. Itu kalau markah 3 kalau markah biasa markah 2 je ni. Width of the central maximum is W equals to 2 lambda D over A. We substitute the values to 600 nanometer. D is 1.5. A is 0.4 times 10 to the 3.
4.5 power of -3.
4.5 times 10 negative 3. Okay, very good. Kalau macam ni, gantian tu dia kasi 1 markah. Sorry, gantian 1 markah. Formula dah tak ada So gantian 1 markah. Final answer with unit 1 markah. Again, tak ada unit. Basically, kamu hilang 1 markah. Ada 50% hilang kat situ. Okay, any question for this question 12? Senang kan?
Final question.
No, sir.
Alright. Let's try to look at question number 13. Calculate the numbers of dark fringes that will be produced on both sides of the central maximum. If light lambda equals to 650 nanometer is incident on single slit, that is 6.6 micrometer width wide. Okay, so dia suruh cari maximum numbers of fringe. Dia tak kata maximum tapi kita dia ada tu. Tak ada cakap kan. Dia kata nak berapa banyak dark fringe tu. So obviously you have to use the formula yang ada sin tu. And then A sin theta, this is the formula, is equals to N ataupun N plus half. Sebab ini adalah dark fringe. So kalau dia bright fringe, dia adalah N plus half. Kalau dia dark, dia adalah N. Okay, lambda is 650. And then size is 6.6 times 10 negative 6 meter. Okay, for N max, theta dia sama dengan berapa? Ataupun sin theta tu sama dengan berapa?
90.
Yes, theta is equals to 90, so that sin theta is equals to 1. So basically you can write down the formula. N max is equals to A over lambda. So A here is 6.6 times 10 negative 6. Lambda is equals to 650 times 10 negative 9. So N max tu sama dengan apa ni?
10.15.
10.15. Okay, so if you get 10.15 numbers, this one is numbers of order. If the question asks you to find numbers of order, so you have to answer 10. Okay, kalau dia suruh sekarang ni suruh kira berapa banyak fringes, so you have to roughly calculate lah. Okay, ini kamu kena round it off kan. So round off dia kepada berapa tadi?
10.
10, okay. Smaller number je, jadi 10 lah. Nombor bulat yang sebelum dia adalah 10. So numbers of fringe, number of dark fringe is equals to 2n. Okay, so untuk dark fringe you don't have to add 1. Okay, kalau yang bright fringe you have to add 1. Macam tadi saya tunjuk, kalau saya nak tunjuk sekali. So basically katakan macam ni kan. Okay, yang ini dia punya center bright. Okay, so basically this is the first, oops, this is the first bright, sorry, first dark. So, bayangkanlah dia ada banyak sampai ada 1 point tu, katakan ini adalah yang ke-10 tu. Okay. So, daripada here, from here, dia ada 10 kat atas, 10 kat bawah. 10 tambah 10, so jadi 20. Kalau apa tu? Kalau bright, you have to add 1 center back fringe. Okay, faham ke tidak? Ini.
Faham, sir.
Faham, eh? So, be careful a little bit. Student biasanya they will calculate up until here. Okay. So, if you calculate only until here, basically you lose lots of marks. Okay. So, biasanya markah dia kalau this one, you get 1 mark for gantian. Okay. And then final answer, jawapan jadi tak ada unit kan, jawapan satu markah. Okay. Kadang-kadang dekat sini dia kasih konsep 1 markah. So basically kalau kamu kira atas ni, normally you get 1 mark je. Okay, buat 30% lah daripada keseluruhan. Kalau kamu stop, dapat 30% je. Yang dua ni tak dapat. Okay, mana lagi soalan? Okay, soalan seterusnya. Let's try to do question 14. The question 14 says intense white light is incident on diffraction grating. Okay, immediately kamu tahu ni adalah diffraction grating lah, sebut itu. 600 lines per mm ni pun ada giveaway lah. Sebab kalau yang diffraction saja dia tak ada per mm tu. Given that the wavelength of red and violet are 700 and 400 nanometers respectively, determine the highest order. Complete visible spectrum can be seen using this grating. Angular separation, violet age, red age, the first order spectrum produced by this grating. Okay, so macam biasalah keluarkan information first. And 600 lines per mm tu dia punya apa?
N.
Yes, capital N kan? Per mm is your capital N. Kalau yang D tu unit dia biasa macam mm per centimeter sebab dia separation. Okay, and then dia kata lambda untuk red, so I just put lambda untuk R is 700. Kalau untuk violet, V is 400. Okay, apa yang berlaku sebenarnya, saya copy di sini. Okay, so diffraction grating ni, dia akan produce pattern dia sama macam diffraction lah. So basically dia produce diffraction punya pattern. So dekat sini dia kata dia pakai white light. So when you use white light, so basically you can see a rainbow over here. So dekat sini kamu nampak rainbow. So basically you will see all the colours of the spectrum. So ada semua colour tu ada lah. Untuk macam rainbow tu semua colour ada. So basically red dengan violet ni will be your maximum dengan minimum. Okay, sama ada red violet tu sama ada duduk atas ataupun dia duduk bawah, antara dua tu lah. So basically bila dia naik, okay, nombor bilangan order tu untuk yang ni lain dan untuk yang ni lain. Cuba kita kira dulu. So sebab dia kata nak highest order, so you just have one formula for the last part ni. 8.6 ni ada satu formula je. D sin theta equals to n lambda. If you want to use D sin theta equals to n lambda, that means for bright fringe, you have to find D first. So kita cari D dulu. Macam saya cakap, you don't have to convert the unit first, you just substitute everything. So the value that you get over here, 1 per 600 here is 1.67 times 10 negative 3. Unit dia ni dalam apa?
Millimeter.
Millimeter. Sebab apa tadi lines per mm. So unit dia adalah mm. So D ni kalau dalam unit SI, kalau millimeter ke meter, you have to divide by 1000. So 1.67 times 10 negative 6 meter. Senang kan maksud dia macam tu. Now you want to find the highest order. So basically n max. Okay. So kalau saya tengok learning outcome, kamu pakai n, so saya keep with n. Ini learning outcome dekat tutorial tu. So formula dia adalah D sin theta N lambda. So kalau untuk maksimum N, sin theta dia sama dengan
1.
1. Okay, very good. So N max dia sama dengan lambda, sorry, D over lambda. Okay. So D over lambda ni kita kira untuk red, violet. Sama ke tidak? So N max is D over lambda. Kalau untuk red, T dia sama, lambda dia yang berbeza 700. 1.67 times 10 negative 3. Okay, violet and max dia yang berbeza adalah dia punya lambda 400. Okay, ini dapat apa ni? 1.67 exponent negative 3, 700 exponent negative 9. Salah kira. Negative 6. Sorry. Ini bukan negative 3.
Negative 6
Yes.
2.39.
Kamu dapat 2.39. Betul? Yang sebelah sini, anda kanan?
4.18.
4.18. Okay, so kamu kena gunakan dia ke nombor terkecil sebelum. So 2.39 ni dia jadi 2. 4.18 dia jadi 4. Okay, so numbers of order, maximum numbers of order adalah 2 and 4 respectively. Okay, but back to this diagram, like I told you before, you can see a rainbow here. What does it mean? Untuk N sama dengan 1, saya kena buat lebih sikit. Okay, so maksudnya bila N dia sama dengan 1 is over here. Okay, yang tengah tu center bright kan, N dia sama dengan 0, and then N dia sama dengan 2. Tadi kamu tanya kan, N dia ada tak sama dengan 0 kat tengah tu lah, tapi dalam formula tak ada lah, tak ada masuk formula N sama 0. Okay, so basically dekat yang pertama ni you can see a complete rainbow. Dekat center tu memang nampak rainbow dia. Yang kedua ni still see a rainbow, the whole spectrum lah, saya tu dia ringkaskan lah. The second tu you still see the whole rainbow. Okay, but bila masuk yang third ni, dekat third ni red is missing. So it's no longer a complete one. Okay, soalan dia tanya berapa banyak yang boleh tengok to see complete visible spectrum. So yang lengkapnya hanya sampai second numbers of order. Okay, therefore complete spectrum. Soalnya nak order je kan, N sama dengan 2. Faham ke tidak? Violet ni ada, violet ni akan ada sampai 4 tu. So yang ketiga tu lagi banyak warna hilang. Yang keempat tu you just left with violet.
So boleh ulang balik tak saya yang 4 rainbow ni?
Okay, 4 rainbow ni basically dekat satu bright fringes ni, sebab yang datang tadi tu cahaya dia adalah white light tau. So white light ni dia consists of all the wavelengths. Okay, so bila dia being diffracted, dia akan terpecah, wavelength terpecah lah. So basically you can see the different colours over here. And then untuk yang middle ni, you can see all the colours because both of yang ni akan minimum dan maximum tau. Yang 400 ni minimum wavelength untuk white light, and this one adalah maximum wavelength untuk white light. So basically for 0 order, first order, second order, you can see all the colours. Tapi bila dia masuk yang third order tu, because yang red ni dia sampai second order je. So masuk yang third order tu, red tu dah missing. Dia tak nampak. Sebab maksimum dia sampai 2 je. Faham tak?
Okay.
Faham sir?
So sebab tu bila kata soalan ni nak complete spectrum, yang complete spectrum masih dekat 0, 1 dengan 2. Yang third tu dah tak ada. That's why kita ambil yang 2. Violet tu dia ada sampai ke 4, tapi warna lain dah berkurang. Jadi spektrum tu dah tak complete lah.
Oh, faham?
Okay, katakan asalnya nampak paling senang lah. Kamu kalau terbayang rainbow tu, kamu terbayang 7 warna kan. So asalnya 7 warna. First order 7 warna. Second order 7 colours. Masuk yang third order maybe tinggal 6. Okay. Yang fourth order tu maybe tinggal 1. Biasanya ada lah in between tu. Maybe third order tu dia tinggal 3 colours je. Pasti dah tak nampak lah after that. Okay. Understand?
Understand, sir.
Alright. Cuba tak lagi satu soalan. Saya rasa soalan yang last ni, saya nak kamu buat sendiri dulu. Tapi dia ada soalan B tu. Okay, kita bincang B. The question 15 tu, I want you guys to try yourself. Okay, we discuss B first. Okay, B tu, saya copy soalan dia. Takut dah terlupa kan. Okay, over here. I want to copy the information as well. So it's the important bit about parts. Okay. Question B, dia kata nak check angular separation between the violet edge and red edge of the first order spectrum produced by this grating. Okay, so macam saya cakap lah, first order ni, bila when n is equals to 1, you can see a rainbow. So basically kamu ada dekat atas sini ataupun dekat bawah situ colour yang berbeza. So katakanlah dekat atas ni, saya tak sure, kena kira balik mana yang satu angle yang besar. Kalau red tu yang besar, maksudnya if I'm not mistaken, red dekat atas lah. So red ni dekat atas, yang violet tu kat bawah. So dia nak check angle dekat sini. Separation between red and violet tu. Itu soalan dia. Okay. Angular separation. So basically you have to calculate theta untuk red and theta untuk violet separately. So to calculate theta, you basically have to use yang formula yang satu tu je lah. D sin theta equals to N lambda. So we want to use D sin theta equals to N lambda. Okay, so yang ni memang dia cerita pasal bright ya. So N je lah. And then kamu punya theta tu, kalau kita nak kira, theta is equals to sin N lambda over D. Okay, N dia ni sama dengan berapa?
Rate tu 2.
Sorry, N sama dengan berapa?
2. Oh, satu.
Satu je kan? So dia kata order. So N dia equals to 1. Okay. So for rate, kita calculate at sin 1. Lambda dia adalah pakainya rate lah. 700 times 10 to 9. D dia adalah 1.67 times 10 negative 6. Okay. If you use your calculator mode in degree, then final answer will be in degree as well. Beza dia dekat lambda je. Okay, so you calculate and then you get theta R will be equal to
7.32 times 10
Kamu pakai
negative 3.
radian
Saya pakai degree, sir.
Degree. Thank you, Ron. Saya dekat 24 point something. Right? 24.78. Cita tekan balik. Cita tekan kot. Theta V here I got 400 and then 9. Okay, I got 13.88. Sorry, 13.86.
Sama sir.
Sama Jadi, okay.
Still sama dengan yang saya tekan tadi. So pakai degree kan?
Kalau saya tak tulis kat sini kot, sign lah sorry. Okay, sebab tu kot adakah sebab tu? Saya punya formula ni bila saya tulis balik, saya terlupa nak tulis sign.
So saya dah dapat dah.
Dah dapat lah? Okay, good.
Dah, saya tak tekan shift sign.
Shift sign kan? Okay. Alright. Saya itu biasa. Okay, anyway. This one dia jadi besar atau kecil lah. R minus violet. Then you get 24.78 degrees minus 13.86. So angular separation 10.92. Okay. Nampak tak?
Dapat sir?
What does it mean? Okay, maksudnya kalau pattern kamu tu macam ni kan. So basically this is the ini dark, yeah, part. This one is dark. And this one is the bright part. Okay, so ini when n is equals to 1. Okay, tapi dekat n equals to 1 ni, macam saya cakap lah, dia nampak macam rainbow tu kan ada multiple colours dekat sini. So yang red tu 24.78 tu angle dia sebenarnya dekat sini. Okay, kalau yang violet tu dekat situ. Dia pada center tu lah. Okay. So angle separation tu yang ni lah. Kita nak kira jarak antara dua angle tu. Bisa nak?